All right. Question number 5, I believe page 4. So question number 5 is all about the speed of waves. Remember, it's the medium that affects the speed, not wavelength and frequency. We can calculate the speed from those things, but the medium is what changes the speed. So let's jump into this. Sonar technician. So we have some sonar submarines. It's going to be sound waves in different types of things, whether that's air, water, whatever it is. It's still a sound wave traveling. So the first one, they find the wavelength. So again, 6,000 hertz pulse. This is the active sonar trying to find this submarine here. And the wavelength is 0.057 in the water. So calculate the speed. Well, this is the fundamental wave equation. Whoops. This is the fundamental wave equation. Velocity is wavelength times frequency. And so the velocity is going to be 0.057 times the frequency of 6,000 hertz. And that's going to be a velocity of about 342 meters per second in the air up here. So we found the speed in the air. Where I'm not sure where it says that, but there it is, air, in the air, right there. All right. So then the technician now places that buoy. So that's what they know about it. Now the technician places that buoy in seawater where the speed is that. So we've now changed the velocity. The velocity is 1,500 meters per second, not 342. So determine the new frequency. Hey, it's tricky. It's tricky. This is tricky. It's tricky. Frequency doesn't change. Frequency doesn't change. So what is the new frequency? The frequency is still 6,000 hertz. It doesn't change when you go from one medium to another. However, the speed does, and thus the wavelength does. So the medium changed the speed, and so the wavelength has to change in order to accomplish that. So velocity is still wavelength times frequency. Now we're at 1,500 hertz, and that's going to equal some new wavelength times the 6,000. And so our wavelength now is only 0.25 meters. Or excuse me, now it's going to be much bigger because it's traveling faster. It's going to spread out that wave as it moves faster there. All right. If the submarine is that distance, 2,400 meters from the sonar buoy, and what, 2 miles, maybe a little less, mile and a half, I don't know. From the buoy, how long does it take this sound wave to get here? So now we're dealing with the other velocity equation. That velocity is distance over time. Well, we know the velocity, and then this is underwater. So the velocity is 1,500 meters every second. We want to go 2,400 meters. And so we're trying to solve for time. And through algebra, you can just swap those two. 2,400 divided by 1,500, time is going to be 1.6 seconds to travel that distance there. All right. Now, it then sends the signals from the buoy to the plane, but it doesn't do that with sound. It does that with radio waves. So now we have a new frequency, light and radio waves, which is just a type of light. More on that next unit, has a much higher velocity. So our velocity now, velocity is wavelength times frequency. Our velocity has a speed of 3 times 10 to the 8 meters per second. So if we want to find that wavelength, we're going to say 3e8 in your calculator equals some wavelength times 2e10 hertz. And so we get a wavelength for light of 0.015 meters. Very, very much smaller wave because light's moving so fast, or back and forth so fast. The electrons are vibrating very, very fast, and thus the electric field vibrates very, very fast, creating that electromagnetic wave. Again, more on that next unit. Frequency of the radio wave increase. So if we change the frequency, we can change frequency, make it a different frequency. What would that do to the speed in the buoy? And it would have no effect. Well, let's see, what's it actually asking? if the frequency was changed, would it affect? So would it affect, I guess technically it's still no, it would not affect it. I'm not gonna say no effect, no. And that's because only the medium affects the speed. And so it's the same medium there. All right. So it's still in the air, therefore it's the same speed. And that is page number 4, question 5.